Okay, welcome. This is the video on Chapter 7F. We are graphing factorized cubics functions. So in the previous chapter, they were in the form where we could see h and k easily, whereas these graphs are going to be more like this, where you've got the three factors, or maybe there's a squared factor and one more. So the first of all thing is that when we have graphs that have a positive x cubed at the start, so like this one, the graph has a positive slope. So this one here has got a positive slope. It's going positive slope. It does have this section of negative in between its turning points, but then it's positive again. So on the whole, it's a positive slope. When it is a negative x cubed out the front, we get a negative slope. So it's starting negative, we've got that bit between the turning points, but then negative again. And so this chapter is focusing on if something, the cubic is already factorized, and you therefore easily know your three x-intercepts. We just need to be able to work out which way the graph is going. Is it going like this, or is it going like this? So having a look at this equation, so a reminder that the x-intercepts are going to be 1, -2, and -1, making each of those factors equal 0 and working those out. The y-intercept is also easy to work out. We'll just make x a 0. So substituting in x as a 0, and you'll find the y-intercept there is -2. And what all this jargon here means, the first one is when x is greater than 1. So here is when x is 1. When x is greater than 1, to confirm that the graph will be above the x-axis when y is positive, we could substitute in a number such as 2, a number that's out here, into this equation, and you will find that it equals a positive answer, so it's up here somewhere. So that's that section of the graph. The next section is between -1 and 1, so that's here. So we could substitute in 0, because that's a number in between there. Could substitute in -0.5, but that'll be really annoying to work out. And so when we substitute in 0, okay, we knew that we got the answer of -2, so where y is less than 0. Third section, between -2 on the x and -1. So we're going from -1 to -2 there. So picking a number, that's actually going to, we have to do -1.5. Substitute that in, we find that y is positive, y is greater than 0, so the graph is coming up here. And then our last section is when x is less than -2. We substitute in -2 into the original, you find that it's a negative number, which means the graph is down here negative. Now, you're probably thinking, well, why do we have to do that? You already explained that if x cubed is a positive, which we know that if we multiply this out, it's going to be x times x times x. There's no negative there for the x's on their own, so we know it's going to be positive. So as soon as we know these three solutions, we just have to start down here, make our way positive, do the turning point bit, and positive again. So part of the reason why we're learning about this process is so that we can apply it to further polynomials, and I guess sort of just check ourselves when things get complicated. And one of the ways we can simplify this process is by drawing a sign diagram. So this is a sign diagram where before you draw the graph perfectly, we actually just put the intercepts out, and then we work out if it's going to be above the x-axis, a positive on the y, or negative. And then we plan that out so that when we go to draw it, we're like, okay, so this one was positive, and then it's negative here, and then positive, and then negative. Sorry, I've just lost my page there. So the only confusing part there is that we're using the words positive and negative for where the graph is as well as the slope. So when we're talking about slope, this whole section here is negative, and then positive, and then that's a negative slope. We're not actually talking about that with the sign diagram. We are physically talking about whether it is above or below the x-axis. So this is where y is positive, is from here upwards, and below here is when it was below the x-axis. So the 4 sections are to here, now it's below, now it's above, and now it's below. And that is what the sign diagram is showing. Here's an example of using a sign diagram. And example 23 is for questions 2 onwards. So question 1 has already been factorized for you. So you just need to draw a sign diagram and then find the axis-intercepts and the y-intercept just by making x a 0. Question 2, it hasn't been factorized yet. So go to example 23 and you'll notice that we actually need to factorize that first. So this part here, they're testing numbers. They are testing factors of -6. So they've tested 1 and it didn't equal 0, so that wasn't one of the solutions. And then -1, it equaled 0, which means that x plus 1 is a factor of this cubic. I've just written this quick by division. That is the long division part, which you need to do, so they're not showing that in every single example now. And they are left with a quadratic, and again, they have factorized that quadratic in that step also. So that was a massive step there that they've just simplified. Go back to the previous chapter if you need help with that. They found the axis-intercepts. -1, +2, and -3. And then this section here is the sign diagram working out. So below -3, so they might substitute in a number like -4. Okay, and they got and substitute into the original. They got a negative y answer, which means it's below the x-axis, and it was above here, below, and above. And so now they're all ready to draw that nice curve to suit that sign diagram. And did they do the y-intercept in this at all? No, but we can easily see that if x is a 0, 0, 0, take 0, it's going to be -6. So the y-intercept will be -6, so that's nice and easy to work out. Question 3, a similar process to question 2, except for it's wanting you to look out for these repeated factors, which you should know about now. So when we have a squared factor, it is going to touch on the x-axis rather than go through. Okay, so that'll impact your graphing, and you can see example 24 for any extra help with that if you need. Cool, thanks. Sorry I'm being monotone and boring. Bye bye.